Hello. All right, today we are finishing up lesson 7.1. I split it into 2 days. Yesterday we focused on the interior angles, and we know that the interior angles is that n minus 2 times 180, because it's the number of sides minus 2. That gives us the number of triangles inside each shape, and then each triangle was 180 degrees, so that gives us the total number of angles for an interior angle. Today we're going to talk about exterior angles of polygons. So polygons, again, are many-sided shapes. We want convex polygons, we want straight shapes with vertices that point out, the basic shapes that you're used to. Now the exterior angles is a little bit easier to work with because the sum of the exterior angles always is equal to 360 degrees. And so it doesn't matter how many sides or how many angles are on the outside, the exterior angle sum is always going to be 360 degrees. It's just the more sides that it has, the bigger or the smaller the exterior angles end up being. Remember that we learned about how an exterior angle is created. If you have a shape and you just extend one of the sides, it's the angle that's not the straight angle. So with an exterior angle, you always have the side and that exterior angle line that makes a straight line. The exterior angle is always the one that's less than 180. So exterior angles are formed by extending the sides, and the exterior angles add up to 360 degrees. Remember that you can always use linear pairs to find the exterior angles because they are created by extending the lines. So the interior and exterior angles make a linear pair. So if you know this one, you can find this one by adding them to 180. Here are a couple examples of what this might look like. So in the triangle, if you take 120 plus 140, that's 260 plus 100 would be 360. You could use those to find the interior angles because you know all the pairs have to make 180. So 180 minus 120 would be 60, 180 minus 100 would be 80, and 180 minus 140 would be 40. And notice that if you added these three together, the interior angles of a triangle should add to 180. So the exterior angle sum of a triangle is 360. Ava, I'm going to need you to go, please. I'm trying to record a video.
This is 15.
Thank you for helping. Sorry, my 5-year-old always wants to help. All right, you'll notice that this is a 4-sided polygon. And so the angles on the outside should still add up to 180. We got 105 and 105, which would be 210. 210 and 110 would be 320, and 320 plus 40, again, would be 360. And the more sides, the smaller the angles get to be, but they should still add up to 360. I'm going to use my calculator for this one. 98 plus 65 plus 111 plus 36 plus 50 is 360. So the exterior angle sum of a decagon. Do you know how many sides a decagon has, Ava?
No.
Mia, do you know how many sides a decagon has?
4.
10 sides. So a decagon is 10 sides, but the exterior angles are always add to 360 degrees. Find the measure of each exterior angle of a regular decagon. So remember, the word regular means that each angle, side and angle, are congruent or equal. And so if we know that it's a regular decagon, that means that each of the outside angles are going to be the same too. So we can take the decagon has 10 sides. So you're going to do 360 divided by 10 is going to leave you with 36 degrees for each one. the measure of the exterior angles of a regular nonagon. So nonagon, remember that means that it has 9 sides. The exterior angles always sum to 360 degrees. It does not matter how many sides it has. And if you want each, I think it's supposed to say each measure of the exterior angles, you're going to do the same thing. You're going to do 360 divided by 9. Since you know that 36 divided by 9 is 4, you know that 360 divided by 9 is 40 degrees for each angle. Ava. What is the measure of an exterior angle of a regular polygon if the sum of the interior angles is 2,520 degrees? So we're going to have to work backwards a little bit. Remember that the interior angles, we need to figure out that the number of triangles that it has, and then we're going to take it times 180 degrees in each triangle. Remember, we find the number of triangles inside a shape by taking the number of sides minus 2 and then timesing it by 180. If we know that that's the interior angle sum is equal to 2,520, we can use this equation to figure out how many sides it has. So you can start by dividing both sides by 180, or we can distribute the 180 through here and get a nice equation to solve. So 180 times n is going to be 180 n. 180 times negative 2 is going to be negative 360 degrees equals 2,520. So we're going to want to solve this for n. You're going to want to add the 360 to both sides. That's going to be 180 n is equal to 2,880. I added that correctly. And then we're going to divide by 180. All right, I'm going to need my calculator quick. Oh, where did it go? Over here, sorry. Okay, 2,880 divided by 180 is going to be 16. So we're going to get n equals 16. Remember, anything over 10 sides is just called a 16gon. 16gon. What is the measure of each exterior angle? So we had to figure out how many sides it had. Now we can figure out what the measure of each exterior angle is. So we want to do the exterior angle total. Whoops, that was supposed to be is 360 degrees divided by 16 angles is going to be, let me think about that for a second. I don't think that divides evenly because 160 and 160 would be 220. Okay, so 360 divided by 16 is going to be 22.5. So 22.5 degrees for each exterior angle on that one. If the interior angle of a given regular polygon is 30 degrees, what's the measure of its exterior angles? So if the interior of a regular polygon is 30 degrees. Okay, so we're going to have to work backwards again like we did in the last examples. Remember that we find each interior angle of a regular polygon. We have to figure out the total and then divide it by the number of sides. That's how we figure out each angle. So let's think through that. Remember, we find the total by taking the number of sides, subtracting 2. That gives you the number of triangles that it has. Then you take that times 180 because there are 180 degrees in each triangle. Then you divide it by the number of sides that it has to get each interior angle. And if each interior angle is 30 degrees, our equation is going to look like this to start. So then we're going to need to solve for n. So we're going to do our solving steps. First, we got to get rid of the divide by n over here. The fraction bar represents division. So to undo division, we are going to multiply by n, because n divided by n is 1. So that simplifies and gets rid of that, because now 1 times n minus 2 times 180 is going to be n minus 2 times 180. And 30 times n on this side is going to be 30n. We will need to distribute the 180, because if we divide by 180 on both sides in this step, you will end up with a fractional n, and you don't want to have to work with fractions if you don't have to. So distribute the 180, and you're going to get 180n minus 360 equals 30n. Now you have n's on both sides. You got to get all your n's on the same side. So you're going to have to subtract 180n on both sides. That's going to leave you with negative 360 equals to negative 150n. And then we can divide by negative 150. See, negative 150 and negative 150 would be 300. So I'm not sure if this works out evenly again. Let's check in my calculator. So negative 360 divided by negative 150, it's going to be 2.4. If the interior angle of a given polygon is 30 degrees, it doesn't make sense for it to have 2.4 sides. What did I do wrong? 80, 30, interior angle sum is 30. What's the measure of the exterior angle? 2.4. 180n minus 360 is 30n. (180 minus 30, 70, 60, 50). I'm not sure what we did wrong here, but I'm gonna have to look back on it. Maybe this needs to be changed. So I don't know. I'll have to come back to it. But this is how you do it. So let's say that we got, what did I do wrong? 30. I don't know. Okay, so anyways, to figure out the exterior angles, you would take 360 degrees divided by the number of sides. But since I can't figure out what I did wrong on finding the number of sides, we'll have to come back to that. I apologize. I think that there must be an issue with the regular polygon being 30 degrees for that interior angle, because it doesn't come out to be an even number of sides. All right, let me see. Oh my gosh, I think I just read this problem incorrectly, and maybe I have to redo the entire video again. Okay, but let's just see how much it is after I do this. I think I just overthought this question. The interior angle of a given regular polygon is 30 degrees. So let's say that we just have this regular polygon and the interior angles are all 30 degrees. Now we know that this polygon doesn't actually exist because we tried and it doesn't have a number of sides. But if it was 30 degrees, then what the exterior angle would be is that it forms a linear pair. And so we're looking for what would the exterior angle be for any of these given ones. And so if the interior angles are 30, then 180 minus 30 would be 150 degrees. So that's the answer for that one. Overthought it a little bit. I apologize. I might go back and re-record. I guess we'll see. All right, determining the value of x on this one. The value of x, if the exterior angle sum is always 360 degrees. So you got to just remember exterior angles equals 360 degrees. So you're going to add up the total here. You're going to have 6x plus 9x plus 2x plus 139 equals 360. So combine your like terms, you get 15, 16, 17 x's plus 139 equals 360 minus 139, 17x equals 221, and then divide by 17. 17 and 10 would be 170, and then you would need 3 more 17s, so x equals 13. All right, last one. The measure of the exterior angles are 2x, 4x, 6x, 8x, and 10x. What's the measure of the smallest exterior angle? So first, do the similar thing as we did in the last problem to figure out what x is. So 2x plus 4x plus 6x plus 8x plus 10x is going to equal 360 degrees. Combining all of our like terms, 6 and 6 is 12, 20, 30x equals 360. Divide by 30. 30 times 10 is 300, and we need 2 more 30s, so x would be equal to 12. Now, if we think about it carefully, if it's 2x and 4x and 6x and 8x and 10x, then 2x must be our smallest exterior angle, and if x is 12, 2 times 12 is going to give us 24 degrees. You could have plugged it back in for all of them, and then you would see that the smallest would be 24 degrees as well. All right, so a quick summary of the whole unit. Remember that we find the interior angle sum by taking the number of sides. We subtract 2. That gives us the total number of triangles inside the shape. We times that by 180 degrees to figure out the interior angle sum. Now, if it is a regular polygon, then we know that all the sides and all of the angles are congruent. So for each angle, you would take that total, the n minus 2 times 180, and then divide it by the number of sides to find each regular angle. And then the exterior angle sum is always equal to 360 degrees for all polygons. And similar, if it's regular, that means that you divide it by the number of sides because each one would be the same, so you can find each exterior angle. And then interior angles plus exterior angles always equal 180 degrees in pairs because they form linear pairs. All right, thanks for watching. Have a great day.